Well, what would we do for adding and subtracting? It turns out that a different rule would really be appropriate, but it's already getting too complicated if we start to add more rules than that. So let's always use the rule, whether you're adding, subtracting, multiplying, dividing, taking the inverse cosine, the number of sig figs in the answer should equal the smallest number of sig figs among the inputs. Let's just let that be our rule throughout this course. It's not perfect, but it's a good rule. It's a simple rule. Let's have one more check of your understanding. Suppose I had to do 0.0250 times 3.60. When I punch this into my calculator, the number comes out to be 0.09. How do I write the answer? Each of my input values has 3 sig figs. My answer should have 3 sig figs. The way that I should write the answer is 0.0900. The next topic I want to discuss with you is not found in our textbook at all. It's the subject of ratios or proportions. It is an idea that we physicists use all the time, and I want you to get familiar with it as much as possible. It seems to be a challenge for some people to get on board with ratios and proportions, so I'm going to take a little time to introduce you. So first I'm going to give you an incredibly simple question to illustrate what I'm talking about. If 1.0 cubic centimeters of material X has a mass of 10 grams, what is the mass of 3.0 cubic centimeters of material X? You don't need a physics lesson to help you figure out the answer to this. You can do this in your head. It's 30 grams. Okay, but what about this example? If 47 cubic centimeters of material Y has a mass of 312 grams, what is the mass of 51 cubic centimeters of material Y? The idea that you used in the first example and that we need to use again in the second example is that for objects of a given substance, mass is proportional to volume. In fact, there is something called density that is a kind of proportionality constant. Later in the book, density is officially introduced, but I'm introducing it right now. Density has the conventional symbol of a Greek letter rho, a lowercase rho, and it means mass divided by volume. For solving this problem, it's better if we rearrange the equation so it says mass equals density times volume. And this is the systematic way to solve a problem like this, guaranteed to work. For object number 1, the one that had a volume of 47 cubic centimeters, we know its mass is equal to the density of material Y times volume number 1, which was 47 cubic centimeters. And we know object number 2 satisfies M2 equals rho V2. It's the same rho in both equations. So I could divide the second equation by the first equation. M2 divided by M1 equals rho V2 divided by rho V1, or in other words, V2 over V1. The rho's cancel. So I could solve for mass of sample number 2 from this equation by multiplying both sides by M1. Without ever actually calculating the density of material Y, I can find what the mass of the second sample would be. The first sample was 312 grams, and the volumes are 51 cubic centimeters and 47 cubic centimeters. The cubic centimeters cancel, and I get 339 grams.